Right, got that. And then we want .NET Knots, that should be on there. And then I could share my screen. It's very technical, this particular part of the evening.
Got that.
That's me in the background, so that's good, that's working.
Got that dot.
Good. All right. So lots and lots of things you've got to get set up. So thank you very much for coming along to .NET Knots. Before we get going, this is a very friendly meetup. So do keep things nice and cordial. There are lots of words there, but it really just boils down to being nice to each other. That's the same for you folks in person, but it's easier to keep an eye on you lot. So it's all good. If you need to find a bit more information about our code of conduct, then do hit that bit.ly up, .NET Knots COC. And you can find out a bit more information. But if anybody has any problems or any issues, then the best way to begin that process, either if you're in person, come see me, or if you're on Zoom, probably Connell will be the person you should go talk to, and we'll take that whole through the process and make sure everyone's happy. We'd like to thank our sponsors for tonight, BGSS, which is where us in-person folks are keeping out of the rain and the cold. So thanks to them. Cordius, they're going to be paying for our food and drink tonight. So thanks very much to Cordius. JetBrains and Calix are both sponsoring some swag, which I'll talk about shortly. And I get to put my company in there because I'm an organizer, and that's what we do. As far as swag's concerned, JetBrains are very kindly sponsoring us a 12-month license to any one of their particular products. And if you don't know what JetBrains do, they make developer tools for developers. So everything from ReSharper and IntelliJ and WebStorm, PHP Storm, packages like that. So do tweet on the hashtag .NET Knots, and at some point we will draw out of a hat a winner for that. Likewise, Calix, they're very kindly sponsoring us a book tonight, which I will ask our speaker, Simon, to choose after his talk. I've got an idea, it might have the word functional in the title, which is fine. So that tweet again on the hashtag .NET Knots for a chance of winning that. And I myself an MVP. You an MVP?
I'm not.
Well, you ought to be. That's wrong.
That's very kind of you, but I'm not.
Yeah, well, we'll perhaps sort that out. Again, if you're interested in becoming a Microsoft MVP, then do approach myself, and I'll happily take you through the process of what it takes to become an MVP. Tonight we've got Simon Painter talking about, you are getting up now, but talking about down the Oregon Trail with functional C#, and we'll be announcing the next talk for next month, hopefully very soon. And with that, I will switch you over to Simon, and you can get on with the interesting part of the evening. As I mentioned before, do put your questions in the chat. And then we'll read them out and answer them that way. But at the very end, we can come off mute and do it like a regular Zoom call if you're online. And for the folks here, I guess, Simon, you're happy with people shouting out during the evening, so we can do it that way. It's just easier to do it that way if that's possible. So thank you very much, folks. And we'll switch over to Simon for his part. It should be that. So all good. And Connell, shout if there's anything that you can't see or you can't hear or any problems, and we can go from there. So,
look good.
Good. That's good. A disembodied voice came out and said it was good. That's Connell.
Wow. Oh, that is spooky. I like it. Can you do that again? Can you do that again?
Yeah.
Wow. Love it. You need to do that more.
Can you hear Simon okay and see him okay?
Yes, he's a very tiny icon on my screen, but
that's what my wife says. But yeah, and apologies for the accent if that's anyone's problem. I had nothing I could do about it. It's the one I'm stuck with. Sort of slightly brum, but not quite as cool. Anyway, let's get going. So this talk, and by the way, and just to reiterate what Pete said, if anyone wants to break in at any point whatsoever, feel free. I'm happy to make this a little interactive. Stick something on the chat. I'll try and keep an eye on the chat window. I have one down here, or else Pete or someone will pass it over. So do it, or just in voice. I'm happy with that too, especially if you make it sound creepy. That's even better. So what this talking about is several things, but amongst them is the sort of things I do when I'm bored. because my wife thinks that I never get bored, but actually very much the opposite is the case. I get bored very, very easily. And when I get bored, I start doing things, techie things mostly, just to keep myself busy. And this is one of the things that kept me going through the pandemic. In fact, the other was, oh, yes, please. Thank you. Yes, that's something Peter's just said, I can have another beer. This is something you're missing out on by not being here in person. There is beer. And there will be pizza. There will be, and you can't have any. So, yeah. So sorry. The one of the things I decided to do was teach myself to draw, and the artwork you can see here. I think I don't know if anyone can see that, and the pointer may or may not be working. But what this artwork here is something I did. This is a slightly earlier one, but hey, I'm getting there. I got myself an iPad and just decided I'd get on with it. And darn it, I got a few pictures done, so I'll try and make sure I include them somewhere. But and my contact details are at the bottom of the slide in case anyone actually wants to talk to me about anything. But the other thing I did, cheers. The other thing I did was I found out that one of the very first important computer games was a game from the mid-70s called Oregon Trail. And I managed to obtain a copy of the source code, and I thought, this is an opportunity. So I've converted it into functional style C# because it's the sort of thing I do when I get bored. And that's what this talk's going to be about. And hopefully I'll teach you a few interesting things about functional programming and possibly the great state of Oregon or something, although I know nearly nothing about it except what's on these slides. So first off, what is functional programming? This is a brief, in a nutshell, description of what it is. So functional programming is a paradigm, not a framework, meaning that it is a style of programming, not an environment in which to program. So the metaphor I usually give is if you have a guitar, which is a programming language, you can play many genres of music on it, depending on your tastes, so long as it is not country and Western music. Preferably rock. I like old prog rock song myself. But it's a paradigm, it's a style. And C# is intended deliberately to support both object-oriented and functional. That is a design choice and something that's been going on since about C#3. So it is declarative, not imperative. There are families of paradigms. There are many of them, in fact, although the two that we will typically ever encounter are declarative and imperative. Imperative is what you're probably used to if you've done object-oriented development. Imperative is very concerned with the order of operations. Start here, go here, loop like this, do this, start with this blank object, modify it bit by bit by bit by bit. It's the sort of thing you would hand to a very simple machine to run around and carry out your oral instructions. Declarative, on the other hand, is less concerned with the detail of orders of operations and the precise details of how you go about constructing and doing whatever. It is more concerned with the results that you want at the end. It's a programming style where you more describe what you want and then leave the precise details to the environment. The version of declarative that most folks will have encountered is SQL. SQL is a declarative language. And if you think about it, take your select and then, I don't know, an inner join and some wheres and some order bys. The order of operations is not the order you write them in. In fact, typically the select is the last thing executed, not always, but usually. So you get the idea. In TSQL, you are not concerned with the order that the lines are executed in or precisely what goes on behind the scenes. You're describing what you want and then telling the environment to get on with it. Thus also with functional style programming. Its properties, mutability, meaning once you have set a variable, you may not change its value or any of its properties ever again. If you want a metaphor on that, it's a bit like mathematical working, where you write out each line and then the next line is probably based on the previous with some modifications, and then the next line on the one before that with modifications again. You can't retrospectively go back and scratch that out and start again where you could, but that's not how programming works. Higher order functions. Higher order functions is just functions which are passed out of a function as a return type or into a function as a parameter. If you want an example, link expressions. Select statements are an example of the use of higher order functions. Those little arrow things that you write, those are shorthands for anonymous functions passed in as parameters. That's a functional concept. And in fact, link is based in the functional paradigm quite deliberately once again. Expressions rather than statements. Well, what's that? A statement is anything which doesn't actually evaluate to something. An expression does. That's the difference. A where is a statement. An if is a statement, unless it's a ternary. A ternary is an expression. And so on. You get the idea. Things like where, for each, while, we don't use those in functional programming. We have other ways. Referential transparency is a fancy word for something also called pure functions. And this is based on the idea that we write functions which, given the same parameters, will always return the same result no matter what you do. No matter what state the whole system's in, same parameters, same result, and they have no side effects. So they don't also subsequently go on and modify an object as well as returning something. That's referential transparency. Recursion, I'm hoping we are all okay with recursion. If not, see my definition I just gave of recursion and carry on going until you finally understand what I've just done. So, pattern matching, used to have to explain this, switch expressions in C#. We've had them since, what, about C#8, C#9, something like that. They're pretty awesome. They're very cool. I will be using some, but hoping I don't really need to use those, explain those any further. And it's stateless. There is no state. Object-oriented development is typically based on the idea that you have a state object which sits there and you will periodically modify it, add to it, or whatever. There is no state in a functional program. The state is a sort of emergent property that comes out of the system as it runs. State as an object is actually a sequence of objects, each one slightly modified from the last. If you have ever used Redux in the React.js framework, then you've seen an example of how we would handle state in functional programming. Oh, good. Right. Hopefully everyone is on board with what exactly functional programming is. But why? Why should I even care? It's very nice beer. So I feel sorry for anyone who's not drinking it right now in a nice environment like this. So why? Reduce code noise. That is, functional programs tend to be an awful lot more concise than their object-oriented alternatives. They tend to use an awful lot fewer lines of code. Consequently, far easier to read. There's far less code structure going on, which would be required in object-oriented to actually be able to do whatever you want to do. Functional code tends to stick much closer to representing simply the logical sequence of operations you want to carry out without any bump around it. So it's easier to read, consequently also easier to debug and easier to modify. It is more testable. Referring back to the concept of pure functions, it's much easier to throw together tests which are predictable in their behavior and easy to set up. It is more robust. There is a claim of some functional languages that once they compile, there is nothing that will actually bring them down again. And that might well be true. I have no reason to doubt it. Not the case with C#, because C# is we're gonna have to make some compromises here or there. It's more predictable, and it also has better support for concurrency. So if you're interested in things like Azure functions or sticking up queue processors in Docker or whatever, then this is probably something you want to have a look at. So that's the point of what we're trying to achieve. Also, I should point out that C# is a hybrid language. It's sort of, these days, it sort of sits roughly in the middle of the sliding scale between pure functional and pure object-oriented. So I can hear a bell chime.
The clock tower's just there.
Wow.
Pretty good view.
Yeah, I'll just abandon this live stream and go and no. But okay, but the point is that because C# is a hybrid, and because it has to maintain backwards compatibility, there are parts that cannot be functional. If we moved over into F#, different story. F# is the .NET framework, sort of more functional language. But C# is always going to have to make compromises here and there. The metaphor I like to use is this here of there are actually about two parts of a shadow, roughly speaking. There's actually about 12, but there's two basic parts of a shadow. There's the dark part there, the A there, that's called the umbra, and the shadowy, slightly grey areas on the edge, that's the penumbra, the Bs. And the metaphor I keep in my head is that the dark part is the purely functional area of the code, and that sits in the middle. And I try and make that as large and dark and solidly functional as I can. And then around the edges of the system where I have to compromise, that's the bits where I'm allowed some non-functional code. And I try and keep those bits as small and pushed as far away from my code as possible. There is a term for it, something like functional core imperative shell or something like that for this particular architectural style. So as the talk goes on, I'll point out a few areas where I've had to compromise and do some slightly less functional code. But again, I try and push them out as far as I can. So moving on to Oregon Trail now, again, I have to be totally honest, until I started working on this game, I had never heard of Oregon. Sort of vaguely knew it was a word and probably a state of America, but in case you're interested, that's where it is. Apparently it's between California and Washington. So now you know. And these are some pictures that I found on the internet of Oregon. And going to be honest, this looks lovely. This looks really nice. I don't know if there's any conferences in Oregon that would like to pay for a British developer to come out and give a talk, but I'm going to carry on suggesting that there might be someone who might like to come if you're offering, because it looks very nice indeed. Nike is based there because they have to be based somewhere, and apparently it's based in Oregon. Named incidentally after the Greek goddess of victory, because I enjoy that sort of trivia, and now you go. And the Goonies, who remembers this old classic? The Goonies, absolutely. Well, you've never seen the Goonies? For shame. Hand in your geek card right now. I haven't seen it since the 90s, in all honesty, so I don't know how well it's aged. But and it is incidentally set apparently in a part of whatever city it's in called the Goondocks, which is why it's called the Goonies. I had always wondered about that. There's your answer. It's the place they're from. But there you go, also set in Oregon. And this is a picture that I found on the internet of the Oregon Trail. Painted from life, I have no doubt. But the Oregon Trail was a historical period in American history, which I don't pretend to know a great deal about. But as I understand it, it was a rush of people moving from one side of America to the other, with the idea that they would set up their own farm or whatever, I would guess, or settlement or house. And they went in covered wagons pulled by oxen. And there was a sort of loose network of trails set up by like fur trappers and things like that, which joined up eventually to form this continuous trail. There's the map. And as I understand it, it went from all the way over to from the west in Missouri and stretched all the way across to the far west of America through some mountain range and then finally out into Oregon, somewhere near the sea. That was the Oregon Trail. So I don't know exactly how long it was, but awfully long. Awfully long. That is a precise definition. This was the only picture I could find that vaguely matched it, but apparently there was a mountain pass towards the end, which was an important feature of the trail. So there you go. I think that's meant to be it over there. And you notice the little guys with their guns there. This is another feature of the game, is shooting and hunting and catching your food. And then trading outposts dotted along was another game feature. So these are all the things that were put into it. But before I talk further about that, I have to take a sidestep. That was the 1800s, 1700s. Now got to move forward into the mid-20th century to this gentleman. His name is John Kemeny. He was, I think he was Hungarian, and apparently a bit of a mathematics genius. I am not, so be warned on that. I am not. But he, amongst other things, worked with Albert Einstein. And I don't know if anyone's ever heard the idea that Einstein was terrible at calculus. He's the one that said it. That was him. He also worked, I believe, as an assistant with Richard Feynman, the physicist. And amongst his other achievements, he became head of mathematics at Dartmouth University in America. And he had a couple of obsessions while there running the maths department. And the big one that I'm interested in was computers. He was absolutely obsessed with these newfangled things called computers. And he thought that computers was the way forward. and something that everybody ought to have a go at. That's terribly short-sighted and it'll never catch on, but there you go. And back in those days, the computer was the size of the basement and was run off punch card. So if you wanted to hand in your program to be executed, you knocked on the door of the nice person who ran the computer. You would hand over your punch card to them, and maybe once a week or so, they'd take all the punch cards they had gathered in a batch, hence batch processing, and take them down to the basement or run each one, take the output, and then you could knock on their door later on and find out what actually happened. It was very long-winded and probably rather prone to errors, because if you made a mistake, you'd have to wait another week and come back again. And he wanted to get around that and to make it so that everyone could have a go at computing on the campus. And so he teamed up with this gentleman here. This is Thomas Kurtz, I believe is his name. And between them, they implemented two highly innovative ideas on the campus in Dartmouth. One was something called time sharing. And the idea was that you still had only one computer, because this thing was colossal, very expensive, but it would share its time between multiple terminals. And the terminals would be dotted all around the campus. And the computer would flick its attention from terminal to terminal. And the terminal, I'll show you a picture of one shortly, it looked like a typewriter, basically. But you could still feel like you were interacting with the computer in something vaguely close to real time, even though there was one computer being shared by all of you. And the other was they wanted a programming language that these computers could work in. The other programming languages of the time were things like Algol and the like. And I don't know if anyone's ever seen these sort of Fortran. I don't know if anyone's ever seen these, but they're not easy to read. I have tried. They are not at all easy to get on with. So they came up with the idea of a programming language which should be readable by anyone. It was the Basic All-Purpose Symbolic Instruction Code, or BASIC. They came up with this, and amongst other features, there's some BASIC. And I don't know if anyone thinks that this would be a very good idea to execute. You'd get an interesting result, and I would agree with what happens, but amongst other things, note that it has line numbers. Every single line had to have a line number. And all you could do in the environment was either overwrite the line with a new line or insert a line in between, which is why they go up in increments of 10. It's so that it made it easy to throw in like a line 15 in between those two if you had to pop it in. The other is that every line then follows with a verb. And that was part of their policy of making everything human readable. There's always a verb pretty much on every single line of code. Everything is a verb. Here, print. Now, because this was basically attached to a typewriter and a printer, in those days, when it said print, it meant it. It actually printed. The go-to, incidentally, is one of the rather infamous features of BASIC, and that is literally go to a particular line. So this, in fact, is an infinite loop. It will print I love functional, which is true, I do, and then go to the next line, which says return to the previous line, and it will just carry on doing that probably until the system memory fills and the system dies. I don't know. They also introduced a new keyword, which at the time was considered quite controversial, and that was input. Now, these days, this is not considered really a very controversial idea, but back then it was. Back then, computing was based on the idea that it was a maths tool. You would feed in your formulae or your algorithm, pass it to the computer, wait for a little bit, and then get back an answer. And that's what it was. At the time, people were thinking, why would you break execution and then wait for user input? But this was something that Kemeny and Kurtz pushed for, input, which is exactly what it sounds like. Basically, the program will then pause at this point, wait for the user to type something in, and then whatever they typed in will be stored in a variable. Simple. And the next thing that happened is that everyone made computer games. And the whole campus there became flooded with computer games, tons of them. Apparently simulations of American football, amongst other things. And I'm sure that was very exciting indeed. Probably. This is the sort of terminal. There you go. That's a timeshare machine. As you can see there, it's a sort of typewriter plugged into this gigantic roll of probably fairly cheap paper. So you would type in your command, wait for a bit, and then the printer would print off what the computer says. There is no monitor. And we are actually pre-Pong at this point. Pong wasn't for a couple more years yet. We don't have BDUs as such. Everything is fundamentally text-based. Actually, I think the very first computer game was a kind of a visual one, but I think it was like array of bulbs on the front of a gigantic mainframe or something like that. And that was like the sort of like 4x4 pixel grid or something. But this is moving on a little. And at this point, everything's pretty much text-based. Then moving on to the early 70s, these three gentlemen here, Don Roerich, Bill Heinemann, and Paul Dillenberg, were student teachers. They were teaching history lessons in a Minnesotan university, and it was about the Oregon Trail. And they had this idea: why don't we spice up this fairly dry topic with a computer game to help everyone learn what this is all about in a way that's kind of fun? And that's exactly what they did. In 1971, they wrote the very first version of Oregon Trail, and it was an absolute hit on campus. Apparently, everyone was playing it, and it was apparently a very sophisticated game for the time. Now, unfortunately, the 1971 version was lost to posterity because it was stored on the mainframe, which was wiped at the end of the semester. But they were approached a few years later in 1975 by, what is this, like the Minnesotan Educational something committee or something? But they were a company that specialized in releasing commercial educational software. And so they approached the guys to recreate Oregon Trail. And this is the 1975 version, which you will find the source code for fairly easily on the internet. So Oregon Trail is an incredibly early example of both shareware and educationware at the same time. That's what it looks like on a slightly more modern terminal. Again, it's entirely text-based and, you know, fairly crude by today's standards. But back then, this was cutting-edge stuff. You know, there's some wizards, and it's got RPG elements, it's got management game elements, and it even has a shooting mini game. Now, you might wonder how on earth a text-based environment can have a shooting mini game. It does, and I shall show you later how they achieved it. It's quite interesting. But typically what will happen is the computer will give you some information and then say, make a choice or enter a value or something like that. And then the computer will carry on with the process. And the whole thing is divided into turns. So it's a turn-based thing. Each turn in the game world represents, I think it's about a week, or it's slightly variable, I think, on the concept of the week. But it's roughly the idea. It's sort of a week has gone by in game time, and these are the things that happen. So you start the game off by making your initial purchases of things like supplies. You've got to buy oxen. You've got to buy thermal gear. There's something that for some reason is called miscellaneous supplies, but looking at the source code, it's actually medical supplies. I don't know why it's called that. And various other things that you need, and some spare money. Bullets is another thing you need to buy ready for that shooting minigame. And then you begin the turn, and then there is a sequence of events that happen. First, you're presented with a list of choices on what you want to do this turn. You can hunt food, visit a fort, or just push on and try and make some extra distance. After that, there is a possible encounter with riders on the path ahead, and that is one of the most complicated bits of the whole game. A sequence of random events will occur. And then finally, towards the end of the game, if you've got that far, you'll go through the mountains where it'll become cold, and then different random events will kick in. Finally, it will check to see, have you actually passed the distance required to get to Oregon or not? If you haven't, let's loop straight back around and have another go. And then that's roughly the whole game. That's simplifying a bit. This is the very beginning of the original source code. Now, I've colored this just to make it a little bit more readable. The original version is entirely text, so it wouldn't entirely look like this. But notice there's a couple of interesting commands here. Rem, like I said, everything is a verb in BASIC. Rem is short for remark. That is a comment. Even the comments were actually a verb-based keyword. Sorry, just want to have a question there. No, okay.
Just wait for the doctor bark.
Okay, fair enough. So in this case, though, the rems, the remark statements are just telling you who wrote this. and when. As I say, this comes from the 1975 version. And then we're printing do you need instructions. Dim, which I think is still used in VB, is constructing an array. There is no distinction really between an array and a string in this. There aren't really types exactly as such. There's sort of loosely a string, which is also an array. There's an integer, and I suppose Boolean, but no, there's no Boolean, I don't believe. Booleans are typically done as integers, which are 1 or 0. So that's about it. It's a fairly basic language, as the name suggests. And in this case, what we're doing is taking an input from the user, storing it in, that's pronounced C string, by the way. That dollar is called string in BASIC. And then the if statement. Now in BASIC, because ifs typically involve gotos, in a modern language, we will say if, and then if the statement matches, we will then go inside the curly braces and do the thing. In BASIC, it's more like if, and it matches, then skip. Otherwise, don't skip. So the logic is usually turned on its head from what we're used to in C# and other modern languages. Then it's printing some blank lines. And so what this is saying is, if the player typed no, then skip well ahead. If they did anything else whatsoever, then give them the great big long lengthy block of instructions, which I shan't replicate in their entirety here. But that is, I don't know if that counts as a bug or what. It's also case sensitive, possibly. Although it could be that some of those systems, they were hard coded for case, I don't know. Luckily, there was a block of rems right at the end of the source, which told me what the variables actually meant. Because for some reason in old BASIC games, you tend to get single letter or letter and a number style variable names like this. And I don't know if that's for purposes of memory or why that is, but this is what they look like. And this thing at the end decodes it into something that makes sense. Otherwise, it would have probably taken me about 3 times as long. So the first thing we need, moving into my version, the first thing we need is the ability to interact with the player. Now, functional programming is based on the idea of no side effects, and there's nothing more impure than a human being. So we need to wrap around those side effects in some way that makes it safe to work with. So this is my slightly crude diagram. I see there's my player, and you see how happy they are. They're happy because they're playing Oregon Trail because it's that good. And right, so straightforward. This is without any layers of abstraction involved. Our player interacts with the console, and then that gets passed into the game. Well, that's no good. First thing we need to do is pop ourselves an interface in there so that we can do unit testing, because one of my goals was to get somewhere close to 100% unit test coverage. Well, that's fine, except we still don't entirely know what's going to come out of the console when we ask for an input on some text. There isn't just one thing that can come out. There's actually a multitude of things if you think about it in terms of behaviors. The user player, I should really get you. I've spent nearly 2 decades in IT, and I've gotten very used to always saying user. So now that I'm writing a game, I'm having to like beat myself to keep saying like the player. They are the player. They're having fun. Unlike me, sometimes staring at this old code. So there are a couple of things that might happen. Okay, the player might enter something, that is some text or something. They might enter nothing. That's probably just by straight up hitting the return key. Or an error might occur. And I don't know what sort of error might come out the console, but I assume it's possible. Anything, it's always possible to have an error. But the point is I want to capture that. Otherwise, we will get unpredictable behavior from our application if the console throws some sort of low-level error, maybe a memory out exception or something. I don't know. So that's why I want to capture these 3 possible states in something close to in some sort of programming structure. And this is what it looks like. Now, this is an example of a coding structure from functional called a discriminated union. Now, this isn't exactly how they really look out in a functional language. In something like F#, you can just conjure up a discriminated union. But here, what I've done is I've created an abstract class called maybe, and I've popped a generic on there, T. So which means that that can be anything. T can be anything. And I've implemented a couple of instances of the abstract class. something, nothing, and error. Those are my three states that I foresee coming out of an interaction with the console. Or with the nothing, who cares what's in that? There's nothing. There's nothing there, therefore there are no properties, that's fine. Then there is the something. That means that they actually put something in. So therefore that has a property, which I've called value, and that's a generic. So again, that could be anything. So if you want to imagine the something, that is a thing in a box. The something is a box, the thing is inside the box. And same with the error. That's got an error attached to it. That's an exception. So that is capturing the fact that an exception occurred, and I've also captured that exception, and here it is inside the error. So if you want a way to understand what a discriminated union is, it is not like inheritance exactly, although I've implemented it with inheritance. It's more like Schrodinger's type. I have a box here. It's a maybe box. I don't know what's inside it. It could be something, nothing, or error, and I don't know. All I know is it's a maybe box. And until I bother to inspect it, I won't know which one it is. If I don't care what it is, I'll just pass it along as a maybe box until someone actually cares enough to open it. That's roughly what a discriminated union is. You can take these an awful lot further and start getting involved with monads and the like, but I'm not doing monads in this talk. I have other talks on that subject if you're really interested. For now, though, this is about as deep into this concept as I'm going, a discriminated union. What it means is I can do things like this. This is my version of a read line. So my version of the read line returns type maybe of string, meaning this returns a string, but it might not. It might have a string if everything worked and the player actually typed a string. If they didn't, well, then I've also got that covered. It might be a nothing. So if you look, the first line is to actually do a real console.read line. That's just actually doing a normal console read. Then doing a string in is null or white space check on whatever came back. If it is null or white space, then return the nothing type. Otherwise, because in an awful lot of cases, that's going to be an error condition, the nothing. There are some times where it might not be, where you might just want them to hit enter. But most of the time, the player entering no text and simply pressing enter will often be an error state. And that might be something we want to specifically prompt them on to say, have another go. And there's also a try catch around the whole thing, meaning that if an error does occur, then it will return an error state. So I will know there is nothing there and I can inspect it to see what is the error and maybe display that to console or something like that. When I say use discriminated union. This is how you might consume it in C#. Now, I think, so it's moaning there because there's no default case, but to be honest, I'm fine with it in this case. I know there's no other case because I didn't create one. I made this thing. There is no other case. So there are a few cases where you can just ignore the green squiggly. This is new style pattern matching from the latest version of C#. So what I'm saying is inspect this variable, which is typed to be the base case, which is maybe. And then each of these will hit inside the switch expression based on which type it is. And based on the type, I will convert it into a string with a different value. So this is turning the Schrodinger's don't know what it is into a solid something, which in this case is a string. But what about read-only operations? Well, I've called it operation here, same basic idea, but rather not read-only, this is with no return type. So the maybe is based on the idea that there is a return type coming back. But what if there's no return type? And all I really care about is, did it work or did it fail? And that's what this is for. Operation, I've call it what you like. Operation, call it success or fail. I don't really mind. And I've inherited off that twice. Success, meaning it worked, and failure, meaning an error occurred, in which case the error is also contained in the failure. And in most cases, when I use this, if success comes back and is the real type, then I can just continue like nothing happened. But if the error occurs, I might write something to the screen. And then I have created a extension method because extension methods have their uses. And it's attaching here to a T, a generic, meaning this attaches to everything in the whole of C#. And what that means is if you call try operation on any variable in the whole of C#, pass it in action, that is an arrow, that'll be an arrow function with no return type. And it'll try to do the action. If the action did not error, you get back a success. If it did throw an error, you'll get back a failure. And then you can decide what to do when you open the box, when you receive it. And this is a version of a write line, which now I've had to use a for each here. This is one of those places where I've had to make a slight exception to my functional rules, and that's because I'm not aware of any way to write an array of strings to the console. So I have to use a for each here, but this is pushed fairly close to the wire or the console as it happens. So this is one of those places where I don't mind making a little exception to how functional I'm being. But yeah, that's all this is doing, is trying to write to the console, and if any error, and because it's wrapped inside a try operation, that means any errors will result in a failure coming back. But I can actually take this concept of the discriminated union another step, because error is still error, nothing is still nothing, but actually there is another level to what a something might be when it comes back. It might be text, or it might be an integer, and that might be important, because there are cases when I expect an integer, especially in this game. More often than not in this particular game, I expect an integer, and anything else would be considered an error state. So I could then make another level of discriminated union, this time with 4 states: text, integer, empty, and error. And based on these 4 possible states inside my box of, I don't know which one it is, that then I can do my logic on the other side to determine what to actually do, whether to consider it an error or whether to pass. So what I'm doing is gradually filtering from the messy, impure, hard to predict, full of pot noodles real world, gradually filtering out possible side effects side by side, step by step, until we're actually then passing into the game engine or the turn engine something with some real meaning behind it. And this means I never need to do another check against integer in the whole of my program. Once it's passed into the game area, the input from the user has been sanitized to the point that I know whether it's of the correct type and whether there's even something there. So that's saving me a colossal amount of effort, but I only have to write this one little block of code to do it, and it's finished. That's what my user input looks like. Same basic things you've seen before: abstract base class, and then about 4 implementations, depending on the type. And that's what my conversion tool looks like. So get the input, write something, that's the prompt, the user saying, like, enter an integer or whatever it says. Read back, whatever, look at whatever they do, look at whether that worked or not, the attempt to write. If it wasn't an error, then we can go ahead and read back from the user. Otherwise, it's an error and we need to just pass the error back. And then finally, with the user read result, we can switch and say, was it a something where a try parse is possible? Was it something otherwise that's not empty or null? Finally, then, was it an error? And then the last item, default, is they clearly just pressed enter, and that may or may not be correct depending on the logic. But that sort of level of logic is more the problem for your game to decide when you make this call. So here's my complete recreation of the original first. It's actually about 800 lines or something like that, but compressed down into a little bit. So what I'm saying is, ask the player, do you need instructions? And capture that in a discriminated union called display instructions answer. Then do a switch statement. And my switch statement says, if it is a text input, that is actually was a string, when the text, switching to upper because we have to be careful about casing, equals yes, yes. In that case, call this true, make this a true Boolean. In all other circumstances whatsoever, whether they just hit enter or type no or anything other than yes, in that case, return false. So that is entirely encapsulating all of the original logic. Now, that's rather easy to expand and maybe put some additional answers besides yes or whatever. But for now, that is just sticking as close to the original logic from the game as possible. The actual logic to write it might look something like this. I've wrapped all of my calls to and from the console in something called user interaction. Should have called that player interaction. Now I think about it, darn it. You see, it's so hard. It's such an ingrained habit. But what I'm saying is if display instructions, that is, they said yes, is true, then write this message. Now, that is an if statement. So this is not functional code. That is an if statement. So in this case, there's no curly brace. It's just a one line. I might give this a pass, but hey, I wanted to see how much further we could go. So I made an extension method called write message conditional, which takes a Boolean and a prompt string. And given that the Boolean is true, then it writes the message. Otherwise, it doesn't. Which means I can convert the whole thing into this. This is the entirety of it. So there's my check for whether the player wants instructions or not, and then call user interaction dot write message conditional, and the write message conditional is display instructions, and then following that is all of the text, which will only display if they actually type yes. Otherwise, there isn't. So that's a nice start. It's a nice start. So there's no statements there whatsoever. So the next part is to manage the inventory. So the player needs to set up their initial inventory, which consists of a team of oxen, some food, some ammunition, some clothing, and some miscellaneous supplies, which is what it's called in the original code, but is in fact medical supplies. My remit was to stick as close to the original as possible, so I haven't messed with it too much. That's what it looked like in BASIC. So there's a lot going on there. It's not very easy to read, partly because of the rather obscure naming convention given to the variables, but it's basically setting a whole load of things to 0, printing things like how much do you want to spend on your oxen team, take that input and store it in A, check A to see whether it's between 200 and 300. If it's not, then write an error message. If it is, then we move on to the next item and simply store A and move on. And then at the end, so the idea, and again, it's going on the idea that if the condition matches, then skip, which is part of how BASIC is. This is a diagram version of the same thing. There's kind of mini loops and over loops inside this sequence. Each one has got a series of criteria that have to be met in order for the game to proceed. And then right at the end, you actually have a spend limit of $700. And if you've gone over your 700, then you have to go all the way back to the beginning again. The only one with any complex decisions to make is oxen, which has to be between 200 and 300. The rest simply have to be more than 0. Apparently, the 1971 version had a bug whereby you could enter negative values into these prompts and actually gain yourself some money somehow by magic. So apparently the 1975 version improved on that with this. So this is one version of what we can do. So I'm getting the input, how much on oxen, come back, and then I've got to put a while, because what I've got to do now is create an indefinite loop, a loop where I don't know how many times it's going to go around until it's finally satisfied. And in this case, the satisfied criteria are they've entered a value that I actually like, is of the right type and in the right value range. And until they do that, I'm just going to keep going around again and again and again. Now, an object-oriented way of doing this might well be a while true, and then finally, when the correct criteria pop up, we'll return out of the while. So we're going to do get a user input, how much do you want to spend? If it's an integer, if the integer is greater than 0, well, actually that's redundant. If it's greater or equal to 200, less than or equal to 300, then we can return. Otherwise, we're just going to keep looping around forever, asking them again. And I've got a message that I'm going to write to them based on which error condition has happened. Well, that's...
Was it, when you said you used a while,
Yeah.
did you mean that you wanted to avoid that?
Yeah, that's what I'm getting to. This is not, oh, we're skipping a slide. We just mentioned the R word. Recursion. Getting there.
I forget to say out loud what that question was if it's important, but if you're getting there.
Yeah. There was a question about whether I was going to replace this with something like recursion or, well, you'll see what I do in just a minute. You might be surprised. So this is not functional code because there is a while statement here. That is not function. We need to replace one of the hardest parts in functional C# is dealing with indefinite loops. Definite loops, that is loops where you have a set of stuff, go from the beginning, go to the end. It's really easy to deal with. That's select statements. Basically do link, and link is one of the best features of C#, frankly. LINQ is awesome. That's easy. This is hard. There is no way built into C# to deal with this situation with anything other than a while loop. This is where we have to get creative. So this is one option, and this is the R word, this is recursion. So what I'm saying here is, let's go to our Oxen spend, the initial version, and then we'll do a check on it. If it's a valid integer within the correct range, we can return it. Otherwise, return the same function again, but with and keep in order to keep trying. Now, you can do this. This is functional, but C# is not recursion optimized. If you're fairly sure that your user is not going to do more than just do this a couple of times, then you're probably okay to do this. But frankly, the amount of memory that recursion uses in C# increases rapidly. If you've got any more than just a few items, you'll suddenly find that the amount of memory consumed is quite phenomenal. And it isn't all that hard to get a Stack Overflow exception. So you can, but be prepared for the consequences. So what's the alternatives? Well, here is an extension method I've created. I'll show you how it's implemented in a minute. It's called iterate until. It's an extension method I've created. And in it, you pass two, this attaches to everything, to any variable whatsoever. And it takes two func delegates as its parameters. The first one is the transformation. That is, what is the process by which old version is transformed to updated version? And it will carry on doing that until the second criteria is another func delegate, which turns that variable into a Boolean. That is, make the decision whether to continue or not. Now, this is functional looking code. There is no statement. We're simply passing two different functions, a worker function and a stop or don't stop function, and it will do the process of iterating through this, checking with the player until we're happy. That's functional. But how do I actually implement this? Well, it's a technique called trampolining, which is a fancy term. Well, actually, it's kind of a funny term, frankly. I think it's based on the idea that you're putting it on the function on the trampoline. It's sort of keeps bouncing and its version of the function again and again and again until finally we're tired of bouncing and we come off the trampoline. But how do I implement this? Hidden while loop, which seems like a cheat because it's totally a cheat. There is no other way. Well, there is another way. I'll get to it in a minute. It's once again one of those areas where a compromise has to be made because recursion is too dangerous a technique to just allow unfettered hidden access to it. In F#, this is different. In F#, they've got tail optimized recursion calls where it'll actually let you do recursion to get a value, and it will not affect things on the stack. But if you have a look in the intermediate language, it's a hidden while loop. It's actually what it is. That's what it compiles to. It's actually a go-to statement. So this is, honestly, I find this a perfectly acceptable answer. There's only one while statement in the whole of my program, and it's there. And maybe one day Microsoft will give us an alternative. And if they do, well, I'll replace this function with a new version, and then we are purely functional. But until then, I'm okay with hiding one while loop and then just leaving it at one. This, incidentally, is the other alternative. I said one of the ways might be surprising. Go-to statements exist in C#. They actually do. This is how you'd use a go-to. Now, this is a fairly powerful bit of code you could use. I would use it very cautiously, maybe only in rare circumstances like this. But what I'm doing is starting with the initial version of what the current version of this is, whatever this is, making a tag, which is called loop beginning, running an update with the update function, checking it. I have to have an if statement, so it's still not purely functional because I still have to check it. You can't put goto inside a ternary if. I've tried. And if the end condition is met, sorry, if it's not, I should have a not on it. There's a not missing there. Imagine there's a not. If it's not met, then go to back to the beginning and so on. So really what this boils down to is another hidden while loop. I'm just implementing my own while loop. So which one you want to do, it's up to you. But both of these are fine. I don't have an issue with either of these myself. So then the rest of them are just get non-zero spends. So the only condition for the rest of them is just that you don't spend less than 0, because that's impossible. That would be the game equivalent of smashing the trader in the face and taking his money and your oxen. So it's not allowed in this particular version. This is not Grand Theft Oregon Trail, although I would play that game. So I just made a generic thing where item name is different each time, and this just gets a non-zero spend for item name, and we can stick all of this in an array. I just do an iterate until there are, basically I ask for 5 different items, and we'll just loop through each of the 5 items until we've got a set of 5 spends, and then we can fit them into their correct places and do a total. So there we go. I've created an array of with an enum that tells you what the current item is, what it is you're getting, where it goes, and this will carry on going until you've got 5. And then once you've got your spends, then we'll do a check to see whether we've gone over your 700 or not with a sum. There you go. That's the even bigger version. I'm not necessarily going to go through all of this, but this is the overarching loop. This is the one that says, do me a complete set of spend counts, spend values, and then do a sum and see whether it's over 700 or not. Now, this actually does use recursion. This actually uses recursion to go back and have another go. I'm okay with recursion at this point because I know there's only going to be a couple of passes. The idea that the player is going to go through all of those spends, give all of those values, and do it more than a couple of times without flipping the table over it beggars belief for me. So I have no issue with simply doing a quick, simple recursion. Then there's the main game loop. So this is the main game engine. So one of the things that's possible to do, there are 2 things that are possible to do to break this loop, this gigantic loop of all the phases of the game. One is reaching Oregon, in which case we stop traveling. The other is dying. Dying is possible in this game. Now, there is a cliche apparently in Oregon Trail that everyone dies of dysentery or something. Now, that might be, I've not played the later version, so I haven't encountered this. In fact, there are only 2 possible methods of death in the 1975 version. You can die of pneumonia or injuries. Injuries covers an awful lot of possible scenarios, but those are your only methods of death, if that's what you've committed to. So what I need to do, though, because there's a lot of phases, and any of these might result in death, most of them. But maybe not the eating, actually possibly the eating. Depends what you're eating. But if at any point your player dies on you, you need to stop the game from running any further. Normally, what we'd have to do is stick an awful lot of if statements all over the flaming shop to say, are they dead yet? If they are, then let's die out early. Let's exit early. What I've done is made an extension method called continue game, which hangs off which takes one of these functions. It hangs off game state and takes a function which turns old game state into new game state with an update. And inside each of these continue games is a check to say, are they dead? If they are not dead, then execute the function I've passed in. If they are dead, don't execute. So if I've got a whole series of about 1, 2, 3, 4, 7 calls to continue game here, if they died in like phase 6, then the next few phases will not be executed because continue game has detected that the player is now dead. So I've only created one flow logically of phases, but the check to see whether death has occurred is built in. So it makes the code an awful lot simpler to look at. This is an incredibly simple and technically not correct version of what a monad is-ish. There's a bit more to it before any real proper functional guys start throwing their shoes at me. I know, but this is kind of close. It's kind of close. It's a monad, a sort of overlayer that exists around a function and makes some sort of decision on how exactly to go about handling the functions separately. I'm not going to talk about those any longer, but you get the idea. So start new turn, select an action, handle eating, and so on, update my mileage, And that's it. And then down the bottom, this is all inside an iterate until. So the iterate until will actually continue iterating until the game over flag is true. That's what continue game looks like. It's a tiny little bit of code, but it's actually saved me a ton of code. Because can you imagine writing that if I didn't have the check against dead or reached Oregon built into each and every continue game? That would be a lot of code. And if I want to throw in a new step as well, dead easy, literally write one line, done. So this is handy. This is a lovely little structure you can use. So moving on to the other phase of the game, because see, I did do some other pictures. There we go. I never actually owned one of those. I never had a NES. And part of me wants a NES because I never had one. Part of me thinks they're probably not that good.
You're also going to go buy a CRT because that won't work on a regular telly either.
That won't work on a normal telly.
Oh. Scan line, CRT to make it work.
Do you know what? I have a VR helmet at home. That's better.
Yeah, that was a retro emulator that you can get for that.
To be, you know what I think is going to happen one day is they're going to make a VR game that's you in a 1980s living room with your like Duck Hunt.
You can get that today. It's already there.
That's the nerdiest thing I've ever heard, and it's awesome. But I did promise that there was a shooting mini game. There is indeed a shooting mini game built in. So how do they do this in text? Like this. What you do is you type bang into the keyboard as fast as you can, and it works out how many seconds. Now, this enter is a slightly complicated version of input, which also captures how long it took you to enter and stuff like that. And I think there's a timeout built into it as well. I'm not 100% sure. I couldn't find a decent manual on HP Timeshare Basic. It's one of their built-in keywords. So as I understand it, it's something like you type bang. If you get it wrong, that's considered 7 seconds. Otherwise, it takes how many seconds you took with a maximum again of 7. And that 0 to 7 is used to determine things like how many bullets did you lose, how much food did you gain. The quicker you do it, the more stuff you get and the less you lose. That's the principle it works to. This is a subroutine. There was no functions as such. There was no concept exactly of functions within BASIC. It just had blocks of code, and it had a go sub command, which would mean go to this line, which is 4,500 in this case. And then when it hit the next return statement, it would return to wherever the go sub was. This is as close as it got to a function in BASIC. So yeah, there you go, the epic shooting minigame. And weirdly, it's actually kind of fun, actually. I quite like it. I've gotten quite good at typing. I grew up playing computer games on a ZX Spectrum, so I am very used to using keyboard. So this is how I implemented it. I wrapped a couple of interaction-based items away because obviously we need a player interaction for the player, but also time, because I need to record how long it took for anybody to do this. Now, that would be datetime.now quite often. And I can't use datetime.now in a pure function. A pure function always returns the same result, no matter what. And datetime is literally different every time you call it. So I have to wrap it into a service. Now, if this was Haskell, it would probably be doing things with monads, but this is C#. Dependency injection is fine. It's still a hybrid language. I'm happy with this. So really what iTime service is just literally a pass through to datetime.now. There's like one line in the implementation of iTime service, and it's just called datetime.now. But it means that when I write unit tests for this, I can feed in the value I want for test purposes. So my shoot is use the time service, get the current time, tell the user to type bang, have a look, examine the return that came back. If it is a text input and the text that was input is bang, then we will do a check on how much time has occurred since then, with maximums of 7 and so on. So there you go. That's it. The shooting minigame, the epic shooting minigame. I'm actually quite impressed because there is something slightly, I don't know, for me at least, this slightly got my adrenaline going. I'm just like, sucker. It's satisfying. I enjoyed it, but I'm a nerd. I enjoy this sort of thing. Then there's the riders on the trail ahead. Anyone remember the big guy? Anyone remember Brave Star? Brave Star. I used to love that, although nobody seems to remember it anymore. I think I'm the only one that does. But there you have it. Brave Star was awesome. Riders on the trail ahead. This was one of the most complicated bits of the entire code base. I cannot tell you how many hours. I see someone did put the shoe back down. Thank you. I hope I didn't mangle anything too badly. But yeah, I've spent hours and hours and hours staring at this particular block of code. Now, this isn't the whole thing. It's actually a lot longer than this. It's actually about twice as long as this. I'm just showing you the beginning. It is a multi-step operation that really doesn't work in a very functional manner. It's first off, we've got RND. RND is still around. In fact, you see that keyword about a bit. That's a random number generator. Plugged into that is a gigantic quadratic. This is actually what it looked like. I don't even know what that means. Luckily, the modern C# equivalent looks nearly the same. So I just copied and pasted it, frankly. Because it's like that particular syntax hasn't really changed. And I think the RND back then could actually only generate between 0 and 1. So if you wanted anything other than 0 to 1, you had to do multipliers and stuff like that to get a real number out of it, or something of that sort. Anyway, the whole point of that M is mileage. It's how many miles you've traveled. And what they've done is this sort of weird curve. I've plotted it on a graph to see what it looks like. It's a sort of weird curve like this. And it was based on the idea that at certain points of the journey, they wanted the encounter with the riders to be more common, and in others it was less common. But then after that, there's another step which says, given there are riders, do they look friendly or not? Fine, and then display a message. The user says, here's some riders. They look either they don't, or just skip and look hostile. Notice there's a semicolon. That's the equivalent of, at the end of some of these prints, that's the equivalent of doing a console.write rather than a write line. So you'll either get the message, they look friendly, they look hostile, or they don't look hostile. So then you have to make a choice based on this. Then there is another thing which in the code flips a Boolean. It's effectively what's a Boolean flag from a 1. I think it's S5 there. It's actually an integer. It flips it from a 1 to a 0 or a 0 to a 1. So first you get the Boolean flag set to say, do they look hostile? Then it flips it again based on the probability that that might be right or you might be wrong in your initial supposition. So there are several levels. Are they riders? Do they look hostile? Was your original decision correct? Now, I explained that fairly easily, but trust me, this took hours to understand what the heck this code was trying to achieve. But I got there in the end. And I reduced it to a fairly small block of code, as it happens. Are there riders? And then I have to, this is a switch. This is actually just like a sort of routing part of the code, which just do the RND as it goes off the screen, because this quadratic equation is colossal. And this will make a decision based on between 0 and 10, whether we should encounter riders or not. If not, then just return unmodified state. If there are, we do the encounter riders updated state, which is all this whole block of stuff. Then we do the do they look friendly, which is actually a randomly, I found out when I looked at it deeper, it's actually between 0 and 9, it should be greater than 7. So generally they do. Are they not what they seem? This is how I, rather than a Boolean switch, modifying the original Boolean, which is what the original code did, it's instead I just created a separate Boolean based on the old one. And then based on all of that, compile those two Booleans into finally something which is, what are they actually? Are they friendly or not? If they're friendly, basically they just sort of wave and everyone's happy. Otherwise it's shooting time, in which case we pull out the epic shooting mini game. And you've got various options which have a lot of effects that you can see down there on the state. Based on what you chose to do, it'll modify the mileage, it'll modify how many bullets you have, and various other things based on shooting out with them. And then there we go, with some message conditionals based on whether they were friendly or not. And then finally, do a check. Here's a dead check. Here's one of the dead checks. I did an update to the final state to say, is dead is equal to the amount of ammunition is less than zero, meaning you've run out of bullets, so presumably the writers will raid over and massacre you, as they are wont to do. That's one example, and the random events are all full of various other dead checks as well. You can go through the mountains and run out of clothes and catch. Well, I think you just die of pneumonia, that sort of thing. Then finally, there's the final turn. This has a little interesting bit in it. This is the check to see whether we've reached the end of the trail or not. And then finally, there's a funny character there, the speech mark 7 thing. Now, apparently there is an equivalent of that in modern C#. But what that did on the original timeshare machine is there was a little bell on the side. And when it encountered that character, it dinged the bell. So what you've got here is you ding, finally arrived, ding, at our Dingan City, ding. Someone has suggested that maybe this is playing a little tune. I don't know. And if anyone has ever actually got an HP timeshare mainframe kicking around, I'd be interested to see what it sounds like. I suspect not, because I don't think it could play different notes. I think it was just going ding, ding, ding like that. But
bell character in the end.
There might well be something like that. So that was Oregon Trail. Other ideas I've had for the future. This is a game that was from about the same time. This is the very first Star Trek game ever made. It was, again, sort of shared around university campuses. And that little E inside chevrons there, that is the Enterprise. Yeah, there it is. I think the asterisks are stars. I haven't played this one. And I believe that what you have to do is fly around and blow up Klingons, which sounds entirely keeping with the spirit of Star Trek. And Gene Roddenberry would have loved it. But there you go. It was a text-based. And I can only assume that in the original timeshare version, it was printing this whole thing every time. And that must have, yeah. That sounds like it was using a lot of paper. I don't know. I can only assume. But I fancy doing this at some point. But this will be a little more complicated because this is actually writing to portions of the screen, specific locations. And can you do that in console?
Yeah.
You can?
Yeah, I think so, yeah.
Might look into this. Might not be as hard as I thought then. I can have a look at that. That sounds like a bit of fun, though. And again, it's a bit of history, too. There's versions of this that I'm absolutely, well, I don't know if the Paramount will probably like drag me out of my house screaming and beat me for touching their beloved property, but the code itself is entirely public domain. There was a Doctor Who one as well. This was one of the first Doctor Who computer games ever made. And as anyone that knows me knows, I'm a huge fan of Doctor Who. This one apparently is so big, and I found the code. It was written in BBC Basic, but it was so big that they had to compress it into a binary format and then just print the binary format in the source code. So what happened is the game starts, it uncompresses itself and then starts running. So that's going to take actually quite a lot of work to make that work. But from what I can tell, the game is colossal and it looks like a lot of fun, but it's an otherwise completely obscure Doctor Who game. There is no picture of the Doctor, incidentally, because they were busy changing the actor and they didn't want to date themselves. I think this was meant to be Peter Davison, the 5th Doctor, but by then he was moving on, so they didn't want to put him on the cover. Zork. I love Zork. Has anyone ever played Zork? Zork, no, never been eaten by a grue.
So the one that was on the
I don't know, but this is this is another very early text. We're going a bit more sophisticated with Zork. Zork actually had an interface which is something close to natural language. It had an interface which allowed you to. This is your stereotypical. You are in a maze of twisty passages, each one alike. Go north, enter. That's Zork. There is also a rather marvelous Hobbit one as well, which is worth checking out. The natural language interface is quite dated by today's standard, but for its time was very sophisticated. So that's it with all of that. If anybody is interested in learning more about function/C#, I am writing a book on the subject. I say writing, as of today, I have finished the last chapter. Well, I say the last. I've still got the conclusion to write. That's just going to be a couple of pages. But all of the technical content is complete.
How long is it going to be before it comes out?
How long is it going to be before it comes out? It is currently planned to come out in the summer.
Okay. Probably not worth folks waiting around to win that book. Quite a while.
It is coming out. It is coming out. The early release version is on the O'Reilly website. It's coming out from O'Reilly Books. If anyone wants to scan that barcode, apparently O'Reilly will give you a couple of months free on their site or something, and you can check out, amongst other things, my book. That also is not my final animal. I don't know what everyone who's on early release gets that animal. I don't know. I have asked my editor, and apparently nobody knows. There is a sort of secret cabal of animal choosers who live in a lofty tower somewhere high above O'Reilly Towers, and when the book's ready, they sort of thump the ceiling with a broomstick, and then an animal is lowered down in a basket. Or I don't know, something like that. But somewhere close to the summer, I will be as interested as you guys to find out what on earth the animal is. Knowing my luck, it'll be something like a naked mole rat, something truly repulsive. But if I could have my choice, I'm quite fond of wrens, but I don't get to choose. But anyway, my book. Be warned, one of the reviewers described it as a mix of hardcore technical content and terrible dad jokes, which it is, unapologetically. Yeah, I keep expecting O'Reilly to like do a proper edit on it, but they've never told me to take the jokes out, and I keep putting more in. Including my recent one, which was a reference to Ferris Bueller's Day Off, which will be hidden somewhere in the book for you to find. So there we go. Oh, it's a ding monad. I like it. I like that idea. That if there is not a ding monad, there must be. That sounds like the sort of thing we need. Haskell probably has one. Right, but that's the end of my talk. Does anybody have any questions? I'm going to slurp some of this delicious beer while everyone has a Mr. Peter.
So, and I might have this completely wrong in my head, but you know, I used to be trying to do like dependency injection, and you got into this hell of where do I stop my dependency injections, like a unit test, everything. Luckily, we can do this in main. And async is another one.
Yeah.
So async, you have to stop somewhere. Again, main can be async now, it used to be. Is there a problem with functional where somewhere you've got to just give in and I cannot make this functional? And is that same?
Okay, so you'd say asking with layers of dependency injection and dependency injection, is there a point where you find that there's too many levels deep to make this? Well, I mean, that's just fundamentally a C# problem. I don't think that's different on functional compared to purely object oriented. Now, I didn't actually use dependency injection in terms of a container on this. I just literally instantiated everything and then instantiated other things inside those. And in something like this, where it doesn't go more than about 2 levels deep, it's fine. That's fine. Otherwise, I'd just use an IOC container. I mean, that's probably not strictly functional, but I'm okay with it in the C# context specifically. Again, we're going to have to make compromises, but an async, there are ways of dealing with this stuff async. There's a section in my book where I go into some detail about how to deal with things like transformation functions in async and how to make it all kind of slightly invisible and easy to deal with. So yeah, there are ways. It's probably beyond the scope of this talk, but it's certainly possible. So no, it's not something I'm very concerned with. Okay, so anybody else have any? Lambda calculus is Turing complete. Okay. Yeah, there's actually a whole load of monads hidden inside C#, believe it or not, as well. And IEnumerable is a monad. So
a fundamental theory, but I forgot what it's called, that says that lambda calculus Turing machines have
right, okay. Fair enough. I didn't know, and apparently I saw a talk at NDC London where someone showed that PowerPoint is Turing complete, and he managed. This was brilliant. This talk is on YouTube. Check it out. He managed to make a little machine learning bot that played noughts and crosses in PowerPoint. It was simultaneously the wildest and best thing I'd seen in a long time. I don't know if London talks are up yet, but this talk's worth watching. I really enjoyed that. It was one of the most fun talks I'd seen in a long time. I love insane projects like that.
From what I remember, it relied on users clicking, but you could restrict where they can click.
Yeah, it was to do with.
They didn't have a choice of where to click.
Yeah. Yes, it was based on something like restricting where clicking was possible, and I think it also used animations as a form of state tracking. I'm sort of working from memory here, but check out the actual talk because that's a really good talk. I enjoyed that. Well, any have we got anything?
Folks can come off mute. You can tell them that.
Yeah. Anybody can come off mute if you want to actually talk. I'm not talking more than I have to at the moment. So
Disembodied head.
yeah, any disembodied voices out there want to talk to us? Is there anybody there?
You can actually stop presenting.
I did look up Bell character is
It is ASCII 7. Is it really? I'm curious. I'm going to have to play with that someday and see how many people we got. Oh, hello. Got a person. Hello.
There's some people.
I can't hear you, but I can see you.
Yeah, most people are.
Oh, and everyone else has got, you've got the same beer, haven't you? Not the actual same one. That would be strange and interesting.
They were very. Yeah. Teleportation of beer. Oh, well, if there's no more questions, thanks very much to Simon for coming along and speaking tonight. He's had to come on like three different trains to come and speak. So, yeah, thank you so much for coming along. So, round of applause for Simon. Thanks again to our sponsors for tonight, BGSS and Chris for sticking here with us and letting us in and do all those things. Thanks to Cordius for the food, which is over there. So us folks that are here in person can go eat some of those pizzas, which...
And you can't have any.
No, yeah, and for the drink as well. Don't forget to tweet on the hashtag .NetNots. I'll accept the rest of today, don't worry. For a chance to win a JetBrains license and also a book of Simon's Functional Choice.
Yeah.
That's JetBrains and Calyx. So thanks very much to those two folks. I will be tweeting out the information about next month's meetup. I've just been a bad organizer and not contacted the speaker for next month, so I need to go ahead and do that. So hopefully there'll be a talk in person next month, but we'll see. If not, it'll be online no matter what anyway. And were you going to say something?
Yeah, if you want to choose a functional book, there is one that's out at the moment. If anybody wants it, I'll just put my face in here. Hello. If anyone wants it at the moment and you can't wait, you don't want to do the pre-release and can't wait for my book, although my book is very exciting, then Enrico Buonanno wrote a book for Manning called Functional Programming in C#. That is a very excellent book as well, and I don't think anyone who reads that will be disappointed by it. Cheers, folks. I can see a couple of the nice comments.
Yeah, thanks very much. And yeah, so we're going to finish up the Zoom part of this for this evening. Thanks very much to Connell in the background for keeping in charge of the chat and to make sure all that was going well. So thanks to that. And we'll catch you all next month. So see you soon, folks.
Enjoy your pizzas.
Yeah, we will. Thanks.
Will do.